Uh, Here with me, I have Zach Wasserman, now an independent consultant supporting Osquery deployments among dozens of companies that use it, talking about some of the lessons learned deploying it in some of those companies. So, Zach, come on up here.
So, how many of you have seen something unexpected when working with Osquery? Raise of hands. Okay, basically everyone. I mean, I think this thing is a beast. It's amazing. It does so much stuff, but it's really complex, and there are a lot of pitfalls that we can hit when working with it. So I'm going to go over 10 pitfalls that I've seen to be common when working with clients, when building commercial products on top of Osquery, and just things that we're seeing from folks who are hanging out and asking questions in Slack. So we'll just run through these, do some interactive demos. Probably some of you will be familiar with some, and hopefully you'll pick up on some that you haven't seen before. So first, the user context is important when executing queries. Let's take a look at some example queries here. Select star from Firefox add-ons. In just a regular Osquery shell, we can run this one. And as we expect, we get a bunch of results here. This is normal, right? But now imagine we're running the daemon. Usually we're doing this as the root user. So we'll just rerun as root. And when we run the same query that just worked, no results. Luckily here in the shell we get a nice helpful warning. Imagine you were scheduling this query in Osquery D. You wouldn't get any warning, you just get empty results. So what can we do to fix this? I think this one is probably very familiar to a lot of folks. Like it says in the message, we can join with the users table to make sure we're getting the appropriate context. And then again, we're seeing this set of results that we expected. This makes sense, right? So coming back to our slides. What's going on is that in these table generation functions in Osquery, sometimes there's a context that the table needs in order to generate the appropriate results. So what we can do in this case with the Firefox add-ons table is join with the users table so it knows which user context to use. And you'll see this kind of issue taking place with other tables like Chrome extensions, like shell history, and most of the time you'll get a warning in Osquery that will help you suss out these kind of problems. But remember, it can be tricky if you're testing in Osquery and then you put this query into Osquery D running as root, you can run into this problem. So the order of join tables can be significant. Now, this looks like the right query to write, correct? I mean, we just went over this. So select star from Firefox add-ons, join users using UID. We're joining with the users table, so it should totally work, right? No. What happened here? So this is a problem with the ordering of the tables that we're using here. Like I said, these data generation functions need to know the user context that they're operating in. And unfortunately, what we have going on here is that the SQLite planner is generating the Firefox add-ons table first and then joining it to the users table. So actually what we need to do is go back to that query that I just demonstrated as the solution to pitfall number 1. And then this gives us our results again. All we did was reorder those tables. Now, this seems like maybe we're sorted on this one, but imagine we just want to filter by the tables that have an identifier with Mozilla. So let's add a where identifier like Mozilla. And this should work now, right? I mean, we just saw that it generates a bunch of results. No. Okay, so what's going on here? we have this SQLite query planner that's trying to be smart and help us out here. And we put a constraint on a column from the Firefox add-ons table. So the optimizer thinks, well, let's generate the add-ons table first and then join it to the users table. But that's not what we wanted. We just saw that we had to reorder things to get it the other way. So there's a way to solve this one. And what we'll do here is we'll use the cross-join keyword. And this tells the optimizer, no, we do not want you to reorder this because we know what we're doing here. And then it works. So again, the order in which we hit these table generation functions affects the constraints that those functions receive, and then it can affect the results that we get out of those. So we need to order the joins so that the tables that require the constraints come after the tables that don't require constraints. And if we need to force the optimizer to do that, we can use this cross-join keyword. Okay, so now we want to read some hashes of files. So I've got this somewhat large file on my machine. It's kind of suspicious, and I'd like to get the hash of that one. And helpfully, here's another one where we get the warning. Cannot read file that exceeds size limit. And look at this. This file doesn't have a hash. I mean, we get SSD, but SHA-1 and SHA-256 and MD5, those are missing. So what's going on with that? Well, we have this read max flag in Osquery, and that prevents Osquery from reading files over a certain size. So we can actually restart the shell with a bigger value for this. And when we do this, we'll see no more warning, and we get the full set of results. So this might be obvious when we're looking at a table like hash, but this affects almost any table or any operation in Osquery that's reading files. So something like the plist table, and potentially even the shell history table. Anything that opens a file is going to be affected by this flag. So if you're seeing empty results that don't make sense, keep a lookout for this flag. By default, that's 50 megabytes. And again, it affects many, many Osquery functions. So you may need to tune that flag to get the desired results. And also keep in mind, we have this flag there for a reason so that a malicious user can't put a huge file somewhere that ends up making our queries time out and effectively disables Osquery or uses up a lot of resources on the system. So it's a balance that we have to find here as administrators of an Osquery installation. JSON escaping and query packs. So I've been browsing GitHub, looking at the built-in query packs in Osquery, trying to find queries that will be useful for me. So here's one from the Windows Attacks pack. And now imagine I just copy and paste this one right into Osquery, and I'm using it to check how this thing works on my system. And now let's look, I've got a Windows 10 VM running that actually does show this IOC. We've got this HKey local machine, software piriform, a GOMO key with a value set in the registry. And so I'll come over here, copy this query into Osquery. We'll run it. We expect to find results, right? No. What's going on here? So this time it's an issue with the encoding that JSON uses versus just the exact string that we want to pass in. So in JSON, if we want a backslash, we have to put a double backslash in. So if we come back and edit this one to make it single backslashes, then we get the value that we expected, right? So this can be really confusing when working with pre-written queries that have special characters like this. And now something that we have to look out for is this common workflow of let's get the query working in Osquery I, and then let's put it into our query pack and schedule it on all our machines. But if we were to just copy this bottom one that just works in Osquery I into the query pack, then it's not going to work in Osquery D when it reads the JSON. So we have to be careful how we're using these things. And something that I'll note is in Fleet Control, which is the new file format that we've come up with for Collide Fleet, we're using YAML files to specify the queries. And here you can actually just put the backslashes in as literals as they are. So the copy and paste back and forth works just fine. So that's just a nice little bit of convenience. Kicking up our feet because we're happy. So command line flags versus configuration options. If we've looked through the options for Osquery, there are many that we might want to tune. For example, let's try setting the extension socket flag, which should set the path that Osquery opens a Unix domain socket on to wait for extensions to connect. I've lost my mouse pointer. Oh, there we go. So here's what that configuration file looks like. And we'll just let this keep running in the background. And let's look for that socket. It's not there. So what happened here, we used a real configuration option. Well, let's take a look at the help. There's a lot there. But check this out. There's two sections, Osquery command line flags and Osquery configuration options set by config or CLI flags. And there's actually a really important distinction in these. The ones in that top section must be set in your command line when you're starting up Osquery. The other ones can be set in the config on the command line or in the configuration that you load later. So this can be like from the file system. This could be pushed over TLS through something like Fleet or any other custom config plugin that you use. So this one's a pretty simple fix. We'll just provide that option right on the command line. And there's that socket that we didn't see before. So the options work, we just have to make sure we specify them in the right place. And remember, we also, if we don't want to have to specify the full command line every time we run it, we have this thing called the flag file, which will let us load up flags as if they were specified on the command line. And so this is completely distinct from the config file, which is a thing that can be reloaded at later times or through the config plugins to set up other configuration. Understanding the intervals that are used in the query schedule. So if we schedule a query, put the computer to sleep, and then wake it back up, when would we expect the query to run? So let's say I've got a query scheduled to run every 10 seconds. So we'll just get Osquery up and running. Right now we have a schedule that just runs a basic query selecting from the timetable every 10 seconds. So here we can see that that query executed once, and we'll let it execute again and then we'll have this computer hibernate. So imagine this is basically like I'm a user on a workstation, and I just close the lid here. So nothing's happening in the Osquery processor or really any of the processes on this machine. Let's start that back up. Mouse pointer. When do we expect this query to execute? It's certainly been much more than 10 seconds since we turned this machine off, and we've turned it back on. So the machine's back on. Query hasn't executed yet. There it is. So this is a really important distinction to make. When we set an interval in the Osquery schedule, we are not setting a wall time after which we expect the query to run. So the Osquery scheduler ticks while the process is running, and it's those ticks that are counting the interval. So this is a really big distinction to make between something like a production server, which is on 99% of the time, and personal workstation in which a user is opening and closing the lid. These things are going to have really different real wall time intervals on when the queries run. So this is something that we need to reason about when we're creating schedules. And now on the flip side, this also means that someone messing with the clock on the computer isn't really going to affect how that schedule runs. So we can reason about these things fairly effectively, but it's just a different kind of reasoning that we might have to use. So events, we have a series of pitfalls relating to events. And the first is understanding how Osquery D and Osquery I interact in the case of events. So we'll run Osquery D, see that some events are collected, and then we'll run Osquery I and look for those events. And Osquery doesn't seem to want to be starting here. Let's see if we can show this anyway. Maybe it has started. So we'll just try to generate some disk events here, and we'll see if this example ends up working. Mount some disk images. I was hoping that you would see that, now let's see. So we can see that Osquery D found some results for this query. So it has been able to receive these events from the disk images mounting and now unmounting. So now we're wondering, like, what's going on inside the system? Well, we'll close Osquery D and we'll start up Osquery I, and we know that there's this disable events flag that we need to turn off if we want to get events, right? So we're doing everything right, we think, and we select from disk events, and there's nothing there. And now what's going on here is that Osquery I by default is starting up with an ephemeral database. So it's only showing us events that take place from the time that we've started up this Osquery I process. If we want to get access to the database that was being used by Osquery D, then we need to explicitly point Osquery I to that database. So let's try doing that. and you'll see that I use this database path flag. So now OSQuery has started looking at the database that OSQuery D was writing to. And there's a bunch of events. So this is an important step to do when debugging this sort of thing. And I'll point out that when we're setting the database path flag, we have to be careful that the previous OSQuery process that was accessing that database is no longer running, because RocksDB only supports RocksDB, which I think there's a talk that's going to be diving deeper into this. But RocksDB, where the events are stored, only supports a single process accessing it at one time. So we need to make sure that we're doing that. Then we make money. Tuning event expiration flags. So here's another way to not find the events that we would expect to find. So I've got a config here with the following, and I've set the events max flag really low here just to make it easier to have an illustrative example. But if we start up this OSQuery process with this config, we'll generate some events. I'll just restart this because I think it will be easier to make the demo work that way. And not working. So we'll just switch back to the slides, and I'll say that what you may have seen here would be a warning that some of the events had been expired from this table. And there are a couple of flags here that control this. The events max flag, which sets a maximum number of events of each type that can be stored, and the events expiration flag, which sets the oldest event that we might store. And this can be a problem if you have a really high throughput of events, but you're only querying every, say, hour or something. The default for this is 50,000 events. So if it goes over that 50,000, and then we run a query against the table, those old events will be purged, and we might wonder on the next run of a different query against that same table, or the next run of that query, what happened to those events. So this is another flag that's really important to tune and reason about, because again, this is here for performance and for safety reasons, so that we're not overloading the buffers that we use to store these things. But if you're using these kind of tables, you have to reason about these kind of things. And more about events. We've got OSQuery D running with events enabled, and we're not seeing the events that we expect to see. So I've got a demo fleet instance that I can use to illustrate this one. So right now I have some hosts enrolled. There are some queries scheduled on these hosts. There are some event publishers up and running. And I want to debug, why are we not seeing these events on some of the hosts? So we can select from the OSQuery events table to get metadata about what's going on with the OSQuery event system. And what I'm interested in is, why are my file events not showing up? So we're just going to filter this by file events and take a look at this. So the event publishers are all active. So that's good. That makes sense. But there's 0 events for these top 2. And these are the hosts I'm wondering, why am I not seeing these events on? And here, there's some file events. We can see that this host has 23, this host has 7. Well, let's come over here and look at the subscriptions. There's no subscriptions set up on those first 2 hosts, so no wonder there are no events coming through there. For the file events table, this is a perfectly reasonable way to debug this. For some of the other ones, we'll have to notice things like, oh, audit's not active on this host. Or sometimes there will be a subscription, but nothing's active. So this is kind of tricky, but if we come in here and take a look and just use our instincts on what we think we should expect in these places, this is a good way to start debugging if we're not getting events coming through that we expect. So yeah, those useful columns, active events, which is the count of events, and the subscriptions columns, those are helpful ones to look at when trying to address this kind of issue. Jump in that pitfall. And identifying expensive queries. So like Jason was talking about, I think most of us have seen that it's entirely possible to write queries that bring down the performance of the system. And we have the watchdog, which helps us restrict the performance that can be used by queries. And depending on our environment, sometimes we have that turned off for various reasons. And even so, it's important to be able to find which queries are using the most resources. So again, we'll use Fleet for looking at this one with those same set of hosts. So we've got OSQuery running a schedule. And we'll select from the OSQuery schedule table. And we'll just do a little ordering here that's going to help us see this data in a format that's a little bit easier to see the outliers in. And now I have a few queries. I have a few queries scheduled here. And take a look at the results that we see here. I mean, we have some queries like select star from processes and OSQuery info that use nearly no time. These columns on the right are the time columns. This is, I believe, milliseconds in system time and user time. And then the wall time is actually in seconds. And these are cumulative over the executions of the queries. So if I'm hashing every file in user bin and user local bin, it uses way more resources than just doing a simple listing of the processes. This is not surprising, really. But if you have a more complex schedule going, doing some ordering like this and looking at what your outliers are and whether these are queries that you really need to be running, or whether you can tune the intervals or figure out ways to write the queries more efficiently, can be really helpful. And another great column to look at is the output size. This is like how much data is being generated by the run of that function. And we can see again that this one's like a huge outlier in this schedule. When we look at the output size, we're not taking into account the fact that there's also this diffing engine that only shows us the results that are changed from the previous run. So there's a little bit of additional layer of complexity that we might have to reason about there. So also, if we're looking at the performance of queries, I highly recommend using this script that's available in the OSQuery repo in tools analysis profile.py. It'll execute a schedule of queries that you have and do a bit of a recording of a relative performance on various metrics for those queries. So that's 10 pitfalls, and I'm sure there are many more to find, but you've got this. And I'll say to folks in this room, which I know there are some of you who are working on the development of OSQuery Core, I think there's a lot of opportunities that are ripe for making the user experience better here. And it would be awesome if we could come back next year and say that most of these pitfalls are something that users don't even have to think about. So thanks so much, everyone, and please get in touch online or in person here while we're at the conference if you'd like to chat more about these things. We've got 36 seconds to go, so if there's one question, I'll take it. Thank you.